Okay, yeah, hello. So I hope you have done very well with your quiz and your assignment that was due on Monday. So I'll look at your quiz and your assignment. I'll give you back your grade by the end of the week, then you can check it. So our target, the next target is going to be your test in 2 weeks' times. So we're going to continue. By that time, we are going to finish chapter 1 and chapter 2, and you get a couple of more sections from this chapter 2 to go on. We talk about the inverse of a matrix the other night, and I show you how we can change a system of the linear equation into so-called a matrix equation. Then application of the inverse give you the result. I give you an example for the system of two equations, two variables. So we're going to continue, give you, officially what's going to be the theorem involved and how we're going to apply it, for example, a system of three equations, three variables. So remember, you already got a method of solving a system of the equation by elimination method. This method is solving the system by finding the inverse. So in your next test, you are going to get two types of question on the system of the equation. One that you are going to solve it using elimination method, like in your on your quiz, and the other one is this new one. Okay, it's not difficult. We're just finding an inverse using the inversion method again. Okay, so it's a short section, and we can check it right away. Okay, so this is it. Let's go to my notebook and give you this one quickly. So this section 1.6, 1.7, they are very basic section that take us to the end of the chapter quickly to be able to get to the to the second chapter. Is the one that we're going to talk about, the determinant. A little bit more involved, but everything would be fine. We would like to get to the abstract part, which is going to vector spaces, chapter 3 and 4 as soon as possible. Okay, so this is going to be the target. So that's a 1.6. We already prepared everything we need by that, argumenting 5.1.5. So basically, we are going to see what is going to be systems of the, systems of a linear equation, system of linear equations, and invertible matrices. Okay, invertible matrices. So this is going to be the target. We talked about the other night, when we talk about 1.5, that basically, if we given a system of the equation, we can quickly change it to the matrix equation, and then by application of the inverse, give us the result. We're going to make it official. Okay, make it official by this theorem. So what's going to be the theorem that we have? Okay, it's easy theorem but very useful. In practice, we apply this one all the time. So what's going to be the theorem? The theorem is that if A is going to be an invertible, invertible n by n matrix, matrix, then for each a column vector n by n constant matrix B, the system written in matrix form, the system of equations, AX equal to the B, that would have one solution, has exactly, uniquely, one solution namely, what is that solution? Solution would be x equal to A inverse B. So this means if you can find the inverse of a matrix A, if you can find the inverse of a matrix A, that's it. This system will have a solution, and the solution is going to be a unique one. Okay, that's one that I did it the other night using a system of two equations, two variables. The proof is clear. It's very easy. See, that's proof. The proof is going to be, so if this B and the, okay, if this B and the invertible matrix X is given to you, then you can check this one. You see, suppose you have a solution. Suppose X is going to be, we want to show that the solution must be of this form. So suppose X is any solution, any solution of this system of AX equal to the B. Then, since A is invertible, in order to get the X, you see, we multiply both sides from the left, if you like, by A inverse. Because A is invertible, that gives you A inverse B. Then associated property, you can put these two together. You see, that is going to be X, okay, is going to be equal to the A inverse B. But you know that this is going to be identity, is like 1. And the IX would be X. So X would be A inverse B. So any solution of this system must be in this form. Okay, so we just find a general formula, if you like, for this system of the equation. And that would be very useful for us. We get the connection between invertibility and the number of the solution that this system would have. Then it makes it quite interesting from now on. Okay, so get to know it. Then we are going to see, especially later on when B is equal to the 0, then this system is going to be called homogeneous, and there is quite a lot of connection when we go on. Okay, so but for the time being, it's just a practical one. We just want to apply this formula to get to the system of the equation. Okay, so that's it. So it depends on the fact that the A is going to be invertible. So that's it. That's how we call this one solving a system of the equation using inverse. So we give you one of them in your next test. So we get 2 questions. One system that you solve it using elimination method, and one system that using it, solving it using inverse. Okay, so that's it as an example. We are going to check this one. Okay, so example, we want to solve this system. Okay, solve. We give you the instruction, solve the system. Solve. I'd like to solve the system by finding, okay, by finding the inverse. So that gives you the hint that you are not going to use the elimination method. Okay, so this is a given system of the equation. We have x1 minus 2x2, 2x2 plus 4x3 equal to 12. Okay, this is the first one. And the second one is 2x1 minus x2 plus 5x3 equal to 18. And then the last equation is negative x1 plus 3x2 minus 3x3 equal to the negative 8. So that's a system. Okay, quickly change it to the matrix equation, and then by finding the inverse, get the solution right away. Okay, so I check the format. You have to tell us what's going to be A. A is going to be a matrix of the coefficients, which is 1, negative 2, 4. And this is going to be 2, negative 1, 5. and the last one is going to be negative 1, 3, and the negative 3. This is going to be the matrix of the coefficient. Okay, and the matrix of the unknown, we know it. This is going to be x1, x2, x3. Okay, and the b is just the constant matrix, which is going to be 12, 18, and negative 8. Okay, so our system now is going to be our a times x equal to b. If we can prove that the a is invertible, so the solution of this system is going to be a inverse b. So the question is, what is a inverse? Okay, so when we change it, it's just finding the inverse of a matrix. Okay, and we talk about the method, inversion method. Remember, we reduce this one into the identity matrix. At the same time, we work on the identity matrix at 3 by 3. Then we get the inverse. So let's do it. Okay, so you just translate it into the. This is, we call it the matrix equation, ax equal to the b, and then you want to find your x right away. Okay, so let's do it. So this is it. We have to work on this part to get the result. What is this? Remember, we start with the what is a and the I. We form this matrix and then we work on it. So it's equal to, you bring the a, and this is going to be 1, negative 2, 4, negative 2, 4, and the 2, negative 1, 5, and the negative 1, 3, and negative 3 of the given system. This is going to be your A. Now we are going to continue with we bring the identity matrix here. Okay, that's it. So you have to work on it. You see, this is going to be, this is A, and this is going to be I. You have to work on this one to change it to the what? To change this one into the identity, and the other part is going to be your A inverse. Okay, so the first column is already 1, so we are done with the first column. So we have to change this into the 0. So the R2, we change it to the R2 minus 2R1. Okay, and this one we just, this is R3, we change it to the R3 plus R1. Okay, to get this 0 right away. So the conclusion is going to be, the first one is going to be unchanged, 1 and negative 2, 4, and you have the 1, 0, 0. The second one, R2 minus 2R1, so this would be 0. Okay, negative 2R1, that's going to be a positive 4. Okay, positive 4, that gives us a, okay, that gives us a 3, and then you continue. And here it's going to be negative 10. Okay, so it's going to be R2 minus 2R1. Okay, so this is going to be negative 8, that gives us a negative 3, and this is, it's going to be 0, that's going to be negative 2. Okay, and this is R2 minus 2R1, that give you 1, and this would be 0. Okay, negative 2, 1, 0. R3 and R1, you add them together, that's going to be 0, and you add these two together, you get the 1. Okay, and this is going to be 1. We get the 1 here, then this is going to be 1. Okay, we get the 1, 1. So that was 0, 1, 1. And then we get the 1 and R3 and R1. R3 and R1, we get a 1, and this is 0, 0, 1. Okay, so this is going to be the resulted matrix. So we are done with the first column. Okay, so we get the first column. Now we are going to work on the second one. So you can switch these two. Okay, let's switch the R2 and the, this is it. We're going to switch the R2 and R3. Okay, to get the one over here, and then at the same time we can make this one into the 0. Okay, so by R1 is going to be R1 plus 2R3. Okay, so that's going to be your R1 to R3, just to make it 0 and then continue. So this is going to be the result. R1 and 2R3. So they're going to be 1, 2R3 make it into the 0. Okay, 2R3 that make it into the 6. 2R3, this is going to be 3. Okay, 2R3, we are here. 2R3 would be 0. And the 2R3 that give us a 2. Okay, 6302. And we switch these two, so it's going to be 0, 1, 1, 1, 0, 1. And this is going to be 0, 3, negative 3, negative 2, 1, and 0. Okay, so we are done with the first column. And nicely, we make this one also 0. So we have to change the last part, change this one into the 0. So what we're going to do is, this is going to be, okay, R3. So R3 minus 3R2. Okay, minus 3R2. That makes this one to the 0. Then we are going to be able to keep going. So we get the 1, 0, 6, 3, 0, 2 unchanged. And this is going to be unchanged. Okay. Now R3 minus 3R2. So that's 0, 0, 3R3 that give you a negative 6, negative 3 that make it negative 5, and that would remain the 1, and that would be a negative 3. Okay, so we're almost there. Okay, remember the target is going to be to make this one into the identity. Okay, so what we need the 1 here and the 0 on the top. So what can I do is I can add the R1 and the R3. And to make this one into the 0, I divide this one by a negative 6. Okay, negative 1, 6, negative 1, 6 of R3. Okay, there to get this one identity quickly. So I have now, see, I have 1, 0. This is would be 0, R1 and R3. This is going to be a negative 2. And this is going to be 1 and the negative 1. Okay, this is a negative 1. So the second one is going to be unchanged. Okay, this is it. We want this one kit. Okay, we take care of this one later. So it's going to be 1, 1, 0, 1. Okay, and here we get a 0, 0. So 1, 6, it's a 5, 6, negative 1, 6, and this is going to be negative 3 over 6. That give you, okay, that give you 1 half. 1 half. Okay, we are almost there. Okay, we did everything, and to make it into the identity, you have to get rid of this part. So what is that? It's going to be R2, make it to the R2 minus R3, and then you're done. So this is it. We get the 1, 0, 0, negative 2, 1, and negative 1, and changed. Okay, R2 minus R3, so 0, 1, 0, 1 minus, okay, that's it. So it's going back here, 6, 6 minus, that give you 1, 6. Okay, R2 minus R3, 1, 6. Okay, and what is this one? 1 minus 1 half would be 1 half. And here we get the 0, 0, 1, 5, 6, negative 1, 6, and the 1 half. As you can see, this is going to be identity matrix. So this is going to be your A inverse. Okay. And so the A inverse is going to be, this is going to be your A inverse. Okay, the A inverse is going to be negative 2, 1, negative 1, and we get a 1, 6, 1, 6, 1 half, and then you have the 5, 6, and negative 1, 6, and the 1 half. So this is going to be the A inverse. Okay, not difficult, nice. Takes a little bit of time, but a nice method. And you are going to see another method to find the inverse when we get to the chapter 2. But we are not done. Remember, this is going to be your A inverse. So the result of the, okay, so the result of the system, X is equal to the A inverse times B. Remember what's the B? B is 12, 18, negative 8. Okay, so we go to the next page and we identify X equal to the A inverse B, and that would be the final answer. Okay, so there you are, the solution of your system. X is equal to the A inverse times B, meaning the A inverse and the B. So this is the A inverse. We got the A inverse as a negative 2, 1, negative 1, and then you have the 1, 6, 1, 6, 1 half, and the 5, 6. Okay, that was the 5, 6. Double check. 5, 6, 1, 6. Okay, I just check this one. Get the, okay, that was the R2 minus R3. So that gives you a, in fact, it's a positive 1, 6, yes? Because we got the R2 minus R3. So that's R2, which is going to be 0, okay, minus R3, so that's going to be, okay, I think that's fine. Because the 5, 6 minus, yeah, you get a 5, 6, negative 1, 6 already, yes, nothing to worry about. Okay, so 5, 6, negative 1, 6, that's what I have. 5, 6, negative, okay, negative 1, 6, negative 1, 6, and the 1 half. Okay, that's your A inverse. You multiply by B. Remember the B is 12, 18, and the negative 8. That's it. You multiply them together. So that give you the result. If you multiply together, this is not going to be difficult. So I just write the solution for you. Okay, it's going to be negative. You know, I write down so that you multiply. It's going to be negative 24 plus 18 plus 8 at the first row, and the second one is 18 times 1, 6 would be 9, 9. I'm sorry, 3. Okay, it's going to be 3, 3 because we multiply together. Because 18 and 1, 6. Okay, would be 3. So it's a 3, 3, 3, 3, 9. And you multiply this one. Okay. So it's going to be 12. That's it. 60 over 6. That give you 10. It's going to be 10 minus 3. And okay, 10 minus 3 and the negative 4. You know that is the row column. You just multiply. You get these numbers. 12 divided by 6. That give you, okay. 12, 6. That give you 2. Okay, I made a mistake here. It's going to be 2, 3, 9. 2, 3. Okay, that's it. When you multiply this, 2, 3, negative 4. Sorry. This is going to be 2. Okay, that's a 2, 3, 2, 3, negative 4. 2, 3, -4, and eventually x is going to be, it must be 2, 1, 2, 1, 11. That's your x. Okay, so conclusion is going to be, so the result is x1 is equal to 2, x2 is equal to the 1, and x3 equal to the 11 is going to be the solution to your system. Okay, it's not difficult. It takes a little bit time to be able to find it. Okay, so these are mostly the things, the terms that you're going to have. Okay, so there are a couple of problems in your book. I just want to explain one of them. This is one of the, you have several of this type, and you may get one of them your next practice one. I give you a hint for this one too. They ask you to solve, okay, solve the given matrix equation. The given matrix equation for x. You have a couple of them. Make sure you know how to handle this type of problems. And this is it. This is the given equation. They give it -2, -2, 0, 1. Then it says 0, -1, -1. And then you have 1, 1, -4. I say this is a 3 by 3 matrix. Then they multiply by x, which is going to be another matrix. So the result is equal to, you see, this is the result, 4, 3, 2, 1. And this is going to be 6, 7, 8, 6, 7, 8, 9. And then you have 1, 3, 7, 9. You see, this is the given equation. You have these type of problems. You see, they want you to solve for x. It's like, in algebra, if you have 2x equal to the 8, so x would be 4 divided by 2, for example. So we divide by the coefficient of the x. In this case, that division would be just the inverse of a matrix. So in order to get the x, you have to get rid of this coefficient. Okay, but your coefficient is a matrix. If you want to get rid of it, you have to multiply by the, by the inverse. So basically, what is going to be your solution is going to be, see, so you multiply both sides by the inverse of this matrix from the left. I want to rewrite it. So your x is going to be, you see, note that your x is going to be from the left, you multiply this inverse. So this is going to be your result. It's going to be this matrix, -1, 0, 1, 0, -1, -1, 1, 1, -4, inverse of this matrix. Inverse of this matrix multiplied by that new one that you have over there. Okay, multiply by 4, 3, 2, 1, 6, 7, 8, 9, and 1, 3, 7, 9 again. You see, this is how you write the solution of your equation, if you like. Okay, so anytime something like the division that we did before, we have to use the inverse. Of course, you have to find the inverse of this matrix. I give you the inverse, you can check it for yourself. Okay, if you find the inverse of this matrix, this is going to be the inverse of the matrix. It's the -5, 9. Okay, -5, 9, -1, 9, -1, 9, a 3 by 3 matrix. So the second row is going to be 1, 9, and this is going to be -7, 9, -7, 9, and the 2, 9. And the last part is going to be -1, 9, -1, 9, -2, 9, and the -2, 9. It's like the one that I did. So this is going to be the inverse of this matrix. And of course, you multiply by 4, 3, 2, 1, and this is a 6, 7, 8, 9, and this is going to be 1, 3, 7, 9. Of course, the multiplication is possible because this is a 3 by 3 matrix and this is a 3 by 4. So the middle one is the same. So the result is going to be a 3 by 4 matrix. So you just do the multiplication for yourself. You must arrive at this, okay, 3 by 4 matrix. Is going to be a negative 3, negative 25, 9, okay, negative, this is going to be negative 25, 9, 25, 9, and the negative 23, 9. That's the first row. The second row is going to be negative 4, negative 40 over 9, okay, negative 40 over 9, and the negative 44 over 9. And the last part is going to be negative 2. This is going to be negative 23, 9, and it's going to be negative 32, 9, and the negative 37. So that would be the final answer. So this is going to be your X. Okay, we just want to give you the experience of how we're going to handle this type of problems. It's one of the problems in your book. I don't know. It's not those odd numbers that you have. So you got to be prepared. You know, we may have something which is going to be shorter to, you know, to apply this type of method, but it's very popular. So you have the inverse of the matrix, so we can handle it. You know, get those type of ideas for the inverse. Okay, so it is going to be the case to find the to get this inverse, to get the numbers. Sometimes they make it easier for you. You see on the test, for example, I give another one to see how they may express this one. So this would be a similar one is in your next practice one. Just a moment to make sure you know it. Okay, so sometimes when it's going to be on the test, we want to see if you know the idea. So we may make it easier. You see, look at this one. We want to know whether you got the idea. We give you the inverse. You see, we say suppose. Again, you have a group of problem of this format. And suppose you have the A inverse, you see. We give you the A inverse in this problem. The inverse is 1, 2, 1. Okay, this is going to be the case that we are going to have. Okay, and the second part is this is going to be 0, 3, 1, and it's a 4, 1, 2. You see, the inverse of a matrix is already given to you. So this means this is invertible. Then they ask you this question. They say, if possible, okay, if possible, find a matrix. Find a matrix, okay, matrix C, such that this condition is held. A times C times A is equal to this matrix. Okay, it's like the equation that you have in algebra. You can have equation dealing with the matrices. So we are ready for it. You see, this is going to be the case. Okay, so the A inverse is given to you, so you don't have to find it. But we want to find this C from here. You see, again, in order to get this C, you have to get rid of this A and the A to release the C. In algebra, you divide. You see, if you have, we want to get rid of this coefficient, if you like, you divide. But this is a matrix. We don't have division in the matrix. but anytime we want to get rid of it, we know how to do it. Okay, so what we can do is we can okay, so so what we can do is we can multiply both sides by an inverse to get this to get the c, to release the c. Okay, so what we're going to do is solution. I just wanted to get to know this type of method, and you already got the inverse. You know that the a is invertible, so multiply by a inverse to see a inverse to get rid of this a, and a inverse to get rid of this a. You see, because the a inverse and the a together, that give identity, and that give identity too. Okay, but you have to do the same to the other side. So it's going to be a inverse, okay, 2, 1, 3, and this is a negative 2, 2, 2, and this is going to be 2, 1, 4. Okay, and the a inverse. You see, so this is the way you get rid of these, okay, these numbers, if you like, because the multiplication is associative. So you put the a inverse and the a together, that gives you c, and the a inverse and the a inverse together. You see, and on the other side is going to be the same. Okay, the same. So what we have, okay, this is going to be I, and this is going to be I. So we got the C from here. You see, C is going to be equal to the A inverse. Okay, it's going to be A inverse, whatever matrix we have, 2, 1, 3, negative 1, 2, 2, and the 2, 1, 4, A inverse. You see, you release the C. It's the way we do it. Anytime there is anything extra, you want to get rid of it, just multiply by A inverse to get these numbers. Now, A inverse is already given to you, it's just a multiplication of matrices. So the C is going to be, you multiply these matrices together. Okay, you multiply 2 by 2, and that give you 2. Okay, so these are some techniques that you got to know it. These are just called matrix equations, like a usual equation that you have in algebra. We can have a similar one in, okay, with the matrices. Again, you have a couple of them in your assignment. You know that you multiply these matrices together 2 by 2, and if you do it, this is going to be the final answer. We get a 46, okay, 33, check it, and this 30. If you have any question, you bring it in. I can show you, and you must arrive. I think that's correct. But anything, just bring it up. I just explain it again. So that give you see, this would be C. So get used to it, to get this type of idea. It's just the role of the inverse is like division. It's not, we don't have division. So anytime you want to get rid of something, just bring this inverse to put them together. Okay, so we have a collection of problems, especially in this section 1.6 and the 1.5. So just this will help you to solve, because we want to prove something. Okay, get the idea of for the invertible matrices. Okay, so that's a 1.6. 1.7 and 8, they are easy, so I try to get it for you. Okay, by Wednesday, then we'll be able to get through this, these couple of more sections that we have to get to the chapter. Chapter 2 is very brief. It's very easy. It's 3 sections, but your next test is going to be chapter 1 and chapter 2. So for the next 2 weeks, we should get to the end of the chapter 2. Okay, that's it. I posted for you. Just have a look at it. So finding the inverse of a matrix and its application. Nice application. Okay, get this. Again, any question you want to come to my office over, I'll be there. But just send me an email. Send me quick emails that on those times that we have that you're coming. So I'll be ready for you. Okay, or any other time. Okay, take care and have a good one.